Welcome to part 2 of the Modular Knock series. In this video, you are going to learn about how to add XPMs into your design to utilize the modular knock. To refresh your memory, the modular knock solution is comprised of 3 main steps. Step 1 is to connect all AXI buses that want to utilize the knock to Xilinx parameterizable macros or XPMs. The second step of the process is to add constraint files, or XDCs, to the design that define connectivity and quality of service parameters for each individual knock connection. And the final step is to run the validate knock command. In this video, we'll focus on the first step. To demonstrate how XPMs are added to a design, I'll use the following example. The top of the design will be RTL, and it will contain a BD with the SIPS IP and a NOC IP with the DDRMC enabled. In the RTL, there is an AXI traffic generator that will access the DDR memory controller on the BD. This is all using AXI memory mapped. To show how AXI streaming works, I'll add 2 AXI streaming traffic generators and 2 verification modules to the RTL. From a connectivity perspective, either AXI streaming master can access either AXI streaming slave. Step 1 of implementing the modular knock is to insert the XPM NMUs and NSUs into the RTL and connect them to the appropriate AXI masters and slaves. I'll use the XPM instantiation template in Vivado to insert the XPMs into the RTL. I'll then connect the XPMs to the AXI masters and slaves in the RTL. Now that you have an idea of how the design looks, let me show you the design in Vivado and add the XPMs to the RTL. Let's take a look at the design in Vivado. This is an RTL top design that includes the BD, the master accessing the DDR from RTL, and finally the 2x2 AXI streaming test cases. Let's take a quick look at the BD. Here we will find the SIPS IP, a NOC IP with the hardened DDR memory controller enabled, and the small block on the lower right is a debug hub. For this design, we can ignore that. Now let's take a look at the PL master in the RTL that will connect to the DDR memory controller. If I scroll down, I see the performance traffic generator. Let's insert the XPM. I'll get the AXI master memory mapped XPM from the language templates. Here you can see all of the XPM NMU and NSU options. We'll use the first. Let's copy and paste this template into the RTL. Let's start with the parameters. These are all documented in the user guide, but the first is the knock fabric. This is either VNOC or BLI. Data width should match your AXI data width. I'm going to modify this to take my RTL parameter. Same for address width. I'll leave these parameters as the default. User widths, interrupt pins, and finally sideband pins. Let me update the template instance name. We'll call it PLMaster to DDR. Now we need to connect all the AXI nets. First is the clock. I'll remove the default template name and replace it with the clock that is driving the XPM. Next is the address write ID. I'll copy this from the block that is driving it. I'll continue this process until all the nets are connected. There we go. I'm all done, and I've tied off a few nets we're not using. Now let's stitch the streaming templates into the RTL. Let's open the streaming module. Here is the master streaming traffic generator. This is inside of a generate statement, and hence there are actually two instances. Now let's instantiate the master streaming XPM from the language templates. Again, I'll copy and paste this template into the RTL. I'll update the parameters, I'll also change the instance name, clean this up a bit, and start making the connections to the AXI master. Now let's look at the slave. Here you can see the AXI stream validation IP. The process here is the same. Copy the template from the language templates, paste it into the RTL, update the parameters, connect the AXI bus to the XPM, and finally update the instance name. There we go. You have seen all the XPMs instanced and stitched into the design. The next quick take video will cover adding constraints to connect these XPMs. To recap this video, I demonstrated how the NOC XPMs are added to an RTL design. I discussed the parameters that should be specified when instantiating the NOC XPM templates. I also showed you where to find the XPM NOC templates in Vivado. That will wrap it up for this video. The next video in the series will discuss how to make connections between NMUs and NSUs. Thank you.